Hey guys, this is Miss Paraso here. Just let me clear that out of the way for y'all. I just wanted to go ahead real quick and I'm going to give you a demonstration. If you were not in class today, this is what we did. It's in OneNote. It's called Day 11 and Algebra and Angles Practice 1. And then on the other side, angles and algebra practice 2. So they're two different pages in your OneNote. So the lesson that I'm going to go over right now is how to approach this. So I'm not going to walk you through this one, but this video will kind of get you on the right track for that there. Okay? All right, let me move my little ladybug icon out of the way for y'all. All right, so I got a couple of practice problems. These ones actually are a little bit, I try to get a little bit more challenging and thought-provoking questions here. So what I'm going to ask that you guys do is that I'm going to start you off with one, and I'll read these to you if they're a little unclear. But to kind of get you in the mindset of how to think and approach. What we want to do right now is we want to apply what we know about angle relationships and also even the triangle theorems. So the exterior angle theorem, the triangle sum theorem, and even I don't think I have any Pythagorean theorem stuff on here. This is all just specifically angles. All right, so let's go ahead and take a look at this first problem here. So we've got the measure of angle 1 is 4x plus 35, and we have the measure of angle 8 is 7x minus 40. If I'm looking at my diagram, I see that I've been given that these lines are parallel. L is parallel to M, so that allows me to understand the relationships between them. So because I've been given these, I need to find the value of x. All right, so I'm going to go ahead and write in what I know. Measure of angle 8, 7x minus 40. All right, so because I'm trying to find the value of x, the first thing I want to do is, well, what's the relationship between angle 1 and angle 8? Okay, if you said alternate exterior angles, that would be correct. Okay, so remember these were your parallel lines. Okay. This is your transversal, and the angles lie outside of the parallel lines and on alternate sides of the transversal. And what do we remember about alternate exterior angles is that alternate exterior angles are congruent. So I can go ahead and set up an equation, and I'm actually even going to kind of slow that back a bit. I'm going to actually say what's the relationship. Angle 1 is congruent to angle 8, and that's because they're alternate exterior, and I'm just using shorthand for right now. So now I can go ahead and set up and solve an equation to find the value of x. So they will be equal in value. So I can use the congruent sign. When I change into the equation, I'll change it into an equal. So go ahead and pause the video right now and see if you can set up and correctly find the value of x. All right. How did you guys do? So again, we said that angle 1 was congruent to angle 8. So here was angle 1, here was angle 8. I just set up my equation and I solved for x. And I'm done because it just said find the value of x. It didn't say what is the measure of angle 1. So if it had said something like this, measure of angle 1, find the measure of angle 1, that means that you need to plug the x value back in and give me the actual value of that angle, right? Okay, let's go ahead and take a look at this next example here. It says, assume the two vertical streets are parallel. Angle 7 is 70 degrees. What is the measure? Again, that stands for measure of angle 4. So we want the degrees. So again, all right, well, it says the two vertical streets are parallel. There's my parallel lines. And here is my transversal. So taking a look, I have angle 7 is 70 degrees, and I'm trying to figure out angle 4. Well, is there any direct relationship between 7 and 4? No, not vocabulary-wise, not like alternate exterior or anything like that. This one's inside, this one's outside. But let's try to make a connect the dot. If angle 7 is 70, then that must mean that angle 5 is 110 degrees because these two are supplementary, they're a linear pair. It's a little hard to see it because we have like such a wide line here, these with the streets, but they are right up next to each other. So if this one's 110, is there any connection between angle 5 and angle 4? That's right, angle 5 and angle 4 are alternate interior angles, and alternate interior angles are congruent. So the measure of angle 4 is 110 degrees. All right. Go ahead and pause this video and see if you can use what you know about your vocabulary and what we've done so far to kind of find the value. So here it's wanting the measure of angle AFE. So pause it and give it your best attempt, then come back and take a look. All right, so for this, my goal is to find angle AFE. I want to take a look at what I already know, okay? Well, I see here that BFC is 50, CFD is 90, and these three angles come together to make a straight line. So I can figure out that angle X is 40 degrees. All right, that's the same thing over here. I can figure out that this angle, all right, if I trace it this way, angle BFC and angle CFD and DFE all come together to form a straight line as well, and that is 40 degrees. Okay, this was 90 degrees. So if I wanted to find this, there's a couple of different ways that you could do it. All right, well, now I can kind of, let me grab another color here. I can also see that angle DFE, this angle right here, and AFE come together to form a straight line, and they're supplementary. So if this is 40, then this has to be 140 degrees. Do you see another way that I could have maybe figured that out without having to go around full circle? Did you happen to see the vertical lines? Look here. So angle BFD is vertical to angle AFE. 90 plus 50 is 140, and that's what it ended up being, was 140. So there was a couple different ways that we could go about looking at and finding a missing angle measure. Okay? All right. In this one, they don't have the line markings, but I should have put on here that line X is parallel to line Y, line M is parallel to line N. So your job here is to find the measure of angle 1. Go ahead and pause that video and see if you can figure it out. All right, so let's take a look. See if you can follow my train of thought. So here's how I approach the problem. I will highlight my steps in blue. So the first thing that I noticed was because this one here was 43 degrees, I figured out that angle 2 was also 43 degrees because it was vertical to the given angle. From there, I was able to find the measure of angle 5 because I noticed that these three angles make up a triangle. So I added those two together to get 100, subtracted from 180, and that gave me that this angle was 80 degrees. So that was for the triangle sum theorem. Well then, if you take a look at my highlighted, these were parallel lines, and this is my transversal. Angle 5 and angle 3 are alternate interior angles, so I figured out that this guy was 80 degrees. Well, since I know that that's 80, I took a look at the relationship between angle 1 and angle 3, and I was like, well, those are vertical, and vertical angles are congruent, so that's how I ended up with my final answer. Now, you'll notice that angle 6 I didn't end up needing or touching, but do you think you could figure out how we might find that missing angle? All right. If you think you got it, take a look here. We have to kind of block out that pink line there. Here are these parallel lines. And we actually, in this set of parallel lines, we have three different transversals. We have this transversal here and here. Okay? So this transversal right here is creating this angle measurement. So I want to see, so I see here's angle 6 right there. So looking at that same line, okay, and an orange line, this angle measure right here is created. So angles 2 and 3 combined are in corresponding position with angle 6. So angle 6, if we added those together, would be 123. Now keep in mind, the stuff that I'm doing here is a little bit more challenging and getting you just to kind of think about how you can use those angles to kind of guide you step by step. It's like connect the dots, and you might not always start in the same place, right? Okay, let's see here. This is another good one. This is a nice algebra-based one. Alrighty. We have the symbol that these lines are my parallel lines. So again, I always like to highlight my parallel lines. Just helps it pop out to me. And then here's my transversal. The directions are to find the value of x and y. Well, again, in order to find the values of x and y, you have to know how the angles that are there that are labeled relate. So I'm just going to kind of label these so I can talk about them a little bit more freely. All right. So in order to do this problem, let's see. Let's start with the x's. Is there a direct relationship? Well, they're both outside of the parallel lines and they're on alternate sides. So they are alternate exterior angles. So I know that alternate exterior angles are congruent. So I can go ahead and set up an equation. 17x minus 70 is going to have the same value as 2x plus 5. All right, so now I can solve for my x value. All right. We've learned about this definition as well, the relationship between these two, right? Well, angle 4 and 5 are congruent, all right, because of alternate interior angles. Do you remember what that relationship was there? These are called consecutive interior, and they actually end up adding together to be 180. And if you think about it, it makes sense because angle 1 and angle 5 are the same value. And angle 1 plus angle 3 would add up to 180. So if these two are the same, and this plus this adds up to 180, that must mean that 3 and 5 add up to 180. So go ahead and pause the video right now and see if you can finish solving for both x and y. All right, guys, there's the math for it. Now, I realize you could have found y in a totally different way as well. You could have said that, hey, these guys are linear pairs. Once you find x, you could plug it in and say this plus this will add up to 180. That's another option. We can also check, just make sure that everything works out. When I plug in 20 to this equation, I get 65, so that's 65 degrees. When I plug in, now remember, these are supposed to add up to 180. When I plug in 20 here, that's 100, that's 115. Those two do add up. Now, what should happen is these are vertical angles, so they should end up equaling each other. So let's see if that ended up working out. Okay, so I got x is equal to 5. Why didn't that work out? Interesting. I'm wondering if the equations were just wrong that way, because technically they should work out, that they would be equal. So let's see. They are alternate exterior. They should be equal. I got 5. Maybe double check my math. If you plug in 5, you get 85 minus 70 is 15. And then over here, 2 times 5 is 10. You get 15 again. So I'm wondering if the person that created this algebraically did not think this all the way through, because technically this and this, they should be the same measure. And this plus this should add up to 180. So I'm wondering if we did it differently, if how that might have worked out. Let me know. Shoot me a message if you solved this problem a different way, what you would have gotten, and if the relationships end up working out. I'd be curious to see that. Okay. All right. I'm going to show you one more problem. I've got like 1 minute for it. Okay. Go ahead and pause the video here. We're going to do this problem right here. It wants you to find the measure of angle T. So I'm going to go ahead and work through it, and then I'm going to show my work. So go ahead and pause the video and see if you can think it out. All right, guys. Here we had the parallel lines. So this is 40. Okay, alternate interior, it's inside. So this is 40 as well. To find the value of x, these two are a linear pair. So I solve for x with 65. Plug the 65 in here, got 115. Then I use the triangle sum theorem to find angle T, and the correct answer was 25 degrees. So this is how you apply the angle relationships to these types of problems to find missing information.